So, hello everyone. This is sprint demo of Project Thoth and Thoth team. This is also the first demo that will be publicly available on the internet. So if we have some audience, welcome. And our first demo is by Hashard. It's about continuous integration with TektonCD pipeline. So Hashard, the floor is yours.
Hey guys. I hope you can see my screen now.
Yes, we can see it.
So we were starting to work on our CI pipeline. We were using Zuul for our CI integrations for managing our applications on GitHub. Simple tasks like adding new codes to our source code repository. So now we want to use OpenShift power. So what we are trying to do is use Tekton, which has its downstream project OpenShift pipeline. So we want to run all our workloads on OpenShift. So for that, we have chosen Tekton for our CI integration, for our continuous integration. So just with brief description, what we want to try to achieve is once someone contributes to our repository in terms of request, we want to do some lint checks, unit tests, and these tests would run and check if the code is proper, and then we want to build an image and try to test it in our test environment if it is integrating with our other code bases. So if simple test like if, for example, if you're using user API, if someone contributes to that, we just want to check if that causes any issues with any other of our modules. So like craft refresh or anything like that. So we just want to check that. And once it's done, we just want to reproduce this whole flow. Like if it's a proper build, then we want to reproduce that into our stage and pro. So we just want to automate all this process. So right now we have this design experimentation, I would say, just to check if this workflow will work for us. So we want to use Tekton for our continuous integration and continuous delivery, and we want to use Argo for our continuous deployment. Let me show you a small experiment which I was trying to do. So I'll first jump into the demo and then I'll explain you what's the logic behind it. So here you see there is a pull request which I want to create to my repository, and I create a pull request. So this pull request is simple. I just want to add a koala file. I just want to see if koala checks can be done on my repository. So I've added a koala file, and now let's see what happens in background. So in Tekton, there is a webhook listener which is listening to this repository. As soon as there has been a pull request, any change in a pull request, or like for example, someone opened a pull request, it triggers an event. The event starts some task, and the task have started to run. So each task, there are simple steps which you want to do to sort of this. So in one of the steps is to run a koala test. So it did run a koala test. Now, so we see that the koala has some issues. Now we want to reciprocate this to the contributor. We just want to see, we just want to show them, okay, there was an issue. Please fix that and update your PR. So what we do is, as soon as this would end, that should provide all the details. Okay, so I was being testing the status, so that's why it's not showing. It goes to status. I want to see how to implement that, but I can show you a previous pull request which I had already worked on, and it sends you a comment saying this is the execution fail and you should be updating. This is still a work in progress, so I need to fix how to do all this commenting. And rather than doing a comment, what we want to achieve is having a status where you must have seen in other CI toolings that once a pull request is done, you see checks running, and we want to show the status over there. So that's the work in progress. I'm trying to do that. Let me just share you some technical. One thing, I need to change my screen. So some technicalities. So how does this work in background? So there is an event listener. It is listening to all the pull requests. I hope you can see my screen.
Yes.
So what it is doing is in a GitHub pull request, it's first trying to check for if the event type is a pull request. So right now we're just trying to listen to a pull request, but we want to achieve where we are listening to a check run. So a check run would be from a GitHub application. Similarly, we want to do it for other processes like an issue and other things. So right now we're just trying to implement for pull requests. So what happens is once there's a pull request, it takes all the information present in it. So right now we are just taking few minor informations like what the pull request URL was, which repository it was contributed to, what's the ID of the pull request, and what's the action done. So action could be like reopen, merged, open, closed, so sort of simple things. So we just want to check that. And what happened here is an event listener will try to bind these values with a template. So this template is the actual core part. This is just tells Tekton what to do. So here is a pipeline run. So in Tekton, there's a pipeline. The pipeline will trigger a task, and task will run all the commands which to be implemented. So here's a pipeline. What it is telling here is to use the pull request number, the repository where it has been contributed to, and the pull request. So this information goes to a pipeline, and this pipeline will specify to a task what task to run. If it's an open issue, what to be done, what task to be run. If it's a close issue, what task to be run. And if it's a task, if we want to do some testing, what to be done. So I'll just show you what we are trying to achieve here. So simple thing, if a task is running, we just want to see, we just want to check, do a simple check. So we are trying to run a koala check, and the koala check result is what being shown there. I'm trying to implement the status. So this will go into a status perspective. So it will be another page where you will see all the results. So that's where we are right now. It's just a simple task. I wouldn't say it's difficult. It's very simple. Now, if anyone wants to just add on to this, suppose a PyTest, so they can just add another task and they can specify that into another task reference in the pipeline, and it will work in the similar manner as it's working right now. So that's what I had for now. If anyone has any comments, feedbacks, and any questions, please let me know. Thank you, guys.
Okay, thank you. Are there any questions? If not, we can proceed to the next demo.
Thank you.
Thank you. That will be by me. And the demo will be about a tool that we developed. The tool is called micropipenv. And you can find micropipenv in our organization. So when you go to thoth-station, where all our repositories live on GitHub, you can find a repository that is called micropipenv. And this micropipenv, what it does, it's simply a simple wrapper, single line script or single file script that can install dependencies into container images. And it supports files like pipenv files, pipfile, pipfile-log, poetry files, also files that are produced by pip-tools, and it can also install raw pip requirements. I prepared a small demo. It's on my GitHub account, so under FreeDex you can find S2I example micropipenv, and it's a simple OpenShift application that has different log files present in the repository. So in case of Pipenv, there are pip file and pip file log. Then for poetry, there are poetry log and PyProject TOML. There are also requirements txt. And the last thing that I will show are requirements that are unpinned. The application is simply a Flask application that starts and prints some response when you access it. So it just prints hello world, so nothing magic. There are installation instructions. So when you process the template that is available on GitHub, you will see that a build starts. The build will look for log files present for your application. So it will first look for pipenv files. In this case, it will look for pip file log and pip file. This lookup is done by micropipenv, and it searches what dependencies should be installed into the container image as part of Python S2I build process to have your application or to build your application. So very first files that are looked are pip file log and pip file. I did that. If you take a look at pip file log, you can see that besides other packages like transitive dependencies of Flask, I requested to install Flask in version 1.01. We can simply double check it with pip file that states direct dependencies, and the pip file log was produced by Pipenv, and it states all the dependencies, so including transitive ones besides the direct ones. When we build this application, the log looks like this. So standard OpenShift build process, and it installs dependencies using micropipenv. So micropipenv finds pip file log, parses it, prints it to build log output. So we keep track of these dependencies in build logs. This will be used in our build analyzers or build log analyzers, where we would automatically, or we already do that, where we automatically find what packages cause builds. So here you can see our pip file log that is printed to standard error, and then there are installed packages. This installation is done one package after another, with possible fallback if some package fails to install because of relative ordering of packages. In the end, you can see that the resulting container image with application and all the dependencies that were installed was pushed into OpenShift's internal registry. So this is managing installing dependencies when these dependencies are managed by Pipenv. Another example that I prepared is a case where users use poetry. In that case, the log file and also managing dependencies is slightly different, but micropipenv can handle that. So here we can take a look at poetry log, that is the log file produced by poetry, and it's very similar to pip file log, except it's written in TOML. So here you can see all the dependencies that are pinned to specific versions. And if we take a look at Flask dependency, you can see that the Flask is installed in version 1.03. That is the different version in comparison to the previous scenario when we used Pipenv. If you take a look at logs, besides some warnings that I produced, you can see again pip file log shown in the standard error output. This pip file log is made by micropipenv during parsing of poetry log. So here we can see that Flask is in version 1.03, and this gives us ability to transparently to have unified build logs across all the package managers. So if users use Poetry or Pipenv, the build log is still the same, with all the metadata, like what packages were installed, hashes for integrity checks. And here you can see the actual installation that is again done by micropipenv, and you can see that the Flask that is installed is in version 1.03. Another use case is when users manage dependencies using pip-tools. In that case, what users do, they maintain two files. One is requirements in, that is very similar to pip file or PyProject TOML that is used by Poetry. And in this file, people state direct dependencies and requirements of these direct dependencies. Here I requested Flask in version 1.1.1. And then I performed pip compile that produced requirements.txt with all the dependencies locked into specific versions, and also with hashes. So requirements.txt was produced by pip compile with -- generate hashes. And it's again just another format how to describe dependencies, and micropipenv can handle also this format. So what it does in the build, it detects that we use requirements in and requirements.txt. The requirements.txt file is loaded and transformed into pip file log. So again, pip file log is the format that we use as a unified layer for describing packages in build logs. So here you can see that the Flask that was installed is 1.1.1, the one that we requested in requirements in, and subsequently was present in requirements.txt. And again, you can see basically the same build log that is produced. The installation was successful, and the resulting container was pushed into OpenShift's internal registry. The last case for requirements installation that is supported by micropipenv is requirements.txt, but these packages, or when packages are not pinned to specific versions, or there are no hashes present for integrity checks. So in that case, we provide requirements.txt without direct dependencies, without hashes, and without transitive dependencies, And here we requested to install Flask in version 2.12.1. Installing dependencies or managing applications that have no log files is not a good practice. So how the log file or build log looks like, it prints big warning that the provided requirements.txt file is not fully locked. And that means that the application can result in different packages when you install or build it tomorrow or 1 year later. And it causes issues also for maintainers, because they don't know with what dependencies your application worked, and libraries change over time. So here is big warning that we produce, and the actual resolution is left on pip. So it's basically the same scenario as micropipenv would not be used. And in that case, pip resolves the software stack and finds what packages need to be installed. As we want to act nicely to users, we show them what was actually installed. And for this case, there was used pip freeze that shows all the packages pinned to versions based on pip's resolution. And this is the stack that was used to deploy application. We cannot produce pip file log in this case. it's not that straightforward. Again, the application was pushed and was running inside OpenShift cluster. You can use micropipenv. We already created releases on PyPI. So if you go to PyPI and search for micropipenv, you find this tool with the README file with more detailed explanation and also other features that I didn't speak about. And this tool was already incorporated into our Thoth S2I Python images. So we maintain our own S2I Python images that are enhanced by Python team, and the latest ones already use micropipenv. We are already in sync with Python maintenance team, who they want to include micropipenv in Python S2I images. So the S2I images that are Red Hat ones. There is already ongoing RPM review. So Lumir from Python maintenance team created an RPM. You can download it from Copper. And just one note, we tested what's the actual improvement by using micropipenv, and there are benefits as shown. So it's one tool that rules them all. So it is capable to parse all the requirements files, print these metadata on standard error output, but we also benefit from micropipenv size. So it's one file that is installed into the environment, and when we compared how many megabytes we saved by using micropipenv instead of pipenv, we saved something like 30 megabytes. And we could also install Poetry to see how much space we would save when Poetry Pipenv would be installed in comparison to micropipenv, because micropipenv can handle both these requirements, both these log files produced by these tools. You can find the demo on GitHub, and if you have any questions, feel free to ask. If there are no questions, we can proceed to the next one, and that is Francesco. Francesco, we cannot hear you if you said something. No, we cannot hear you. And we still cannot hear you. So, meantime, Dominic, are you ready to present?
Oh yeah, I can try.
Okay.
Start sharing. So, just give me a sec. So, do you see anything perhaps?
Yes, we see same label system.
Wow, wonderful. Okay, so welcome to my demo, or moreover presentation about a new proposal for label system that would be used within AICoE and thoth-station repositories in GitHub and also in GitLab. So first off, why we should declare a new label system for repositories? Right now, we don't have any structured way of or definitions of how the labels used in repositories. So it's kind of messy way and it's not a unified solution. And the other reason was to more port our project source ops metrics, where we analyze the health status of a repository based on different parameters, and one of them would be also the analysis of labels within issues and pull requests. So therefore I present the same label system that I have read about on the net, and I've made a document about it. So what's the basics of the same label system? It's a way of defining labels based on their type and a subtype. You can tell. Basically, the basic proposal is to use only one instance of label type within an issue or a pull request. That was at the beginning. Now it seems that it's not that strict, but I will get to that later. And that's just the syntax, that's just the rules of how it should be applied. And I also made a notion about the color, because the color should be also the color should also use some system of how we color the labels, because the color fundamentally means something to the human. So I think it should be important to also include some color system within labels. And what I tried was to imply with color the importance of an issue. And it is now it is understood that when you have a label that has a more reddish color, it's like the most important label within the type. And if you go more to the right, you have the labels that are not so important. So the idea is that a contributor would see at first how important the issue is to solve. Okay, and another thing was also that the GitHub supports also a colored text, or more a black text and a white text. So that will be also a useful thing to use, but I didn't get any research on that, or I couldn't find any research. So this is a still question of how it should be used, but I got an idea, but I'm not still sure about that. We could use a white text for the labels that are dedicated to bots, and the black text to the labels that are dedicated to everything other than bots, but I will get to that later also. So, okay. So I propose some basic labels based on some observations on some projects on GitHub, more specifically on OpenShift projects or OpenShift repositories. And the first labels that I proposed was the status labels that are different for issues and for pull requests. So status labels for issues are basically just a notion of just an indicator of in which status the issue is. So if a person looks at the issue, he or she can tell if the issue was, for example, accepted by the team, or if the issue was already completed, or if the issue is work in progress.
And we cannot hear you. Hopefully.
Yeah, I can't hear you too.
Dominic, are you still?
It should work.
It should work. That was the last sentence. So that's becoming more and more tricky.
Oh, I probably have a disconnection. Can you hear me?
Yes,
Yes, we can hear you now.
Sorry about it. Sorry. Which part didn't get to? Or which
You were
part
in
did I finish?
statuses. You were
Status
in
is
status. Yes.
yes. So I said that I also defined the work of how this should be, or it should should look like, and Marek pointed
Dominic,
out that we
losing
link
you,
Trello cards.
and we cannot see what you're presenting. And
Oh,
we are
man. Okay, so I'll find a. Can you give me a second?
okay, you have it.
Okay.
Don't worry, we'll just edit you out.
Можешь это просто заткнуть? Meeting. Okay, can you hear me now?
Yes.
All right, just wait a second. Okay, I'm back. So, as I said, Marek proposed a way of linking the Trello cards with issues, with issue labels. And how that would work is that we would have actually a bot that would be scanning through the Trello cards or through the issues, and the bot would scan if an issue has a corresponding Trello card, and it would label the issue based on in which state the Trello card is. Pull requests, they should also have a status label, but the status label would be used differently. In issues, you would have only one status label within the issue, so the issue cannot have any other status label than one. So, but in the
if you're presenting, we cannot see it.
Really? Oh. Okay. Now it should be available.
Yes, we can see it. Okay.
Okay. Sorry for the internet connection, but recently it gotten worse. So, okay. So the pull request should have also a status label, but it would be used differently, because the status label would actually inform the contributor what things status label pull request needs to be completed. So I've added some examples like failing cola and failing test. It is just a failing test is the failing cola is just for that the source code needs refactor to satisfy the PEP rules, for example. But failing text would be something different. It would be, I don't know, it just don't passes an security issue. And all the others, like needs rebase, needs resolve conflicts, it just means that pull requests cannot have any of these if the pull requests if the pull request can be completed. It's somehow a requirement for the pull request to be completed. But the question is if we really need the labels on pull request, because in the pull request you can see what things it needs to be completed. So I would probably write a question about it because I'm not so sure. Another thing would be size. That's just the thing we have now, but what I think we can use would be the grayscale on the size labels, because the size is not so important to notice at first, in my opinion, and the grayscale just is not so colorful. Another label would be the type label. We some kind of have it now, but this is like a more structured way of types. And also the question is because at the beginning I thought that you could have only one type for an issue. So if you have one label type for an issue, you cannot have any other. But that's the question, because you can have also an issue that informs the contributor about security, vulnerability, and also a performance bug comes with it. So I would probably also write a question about it in the document in form of comment to be open to discuss, because on one side I thought that having issue only one type label would imply simplicity, but on the other side it just doesn't apply to the real side of the problem. Yeah, and another type would be priority label, and this is the main reason why a proposal was made, because in the source ops metrics project we analyzed time to close an issue, and I discussed with Marek what the time to close an issue actually means. And it is not so clear, because you have to differ between time when the issue was recognized by the team and the time when someone actually started to work on an issue. So, and the reason was that you know that the issue was accepted when the status changed from pending to accepted, and you would have priority for issues like in form of what should be done first, and just basic low, normal, high, critical. And also the type labels would have also some kind of priority, because some things are more important than the others. So for example, if you'd have a security issue, you would have to complete it first, I guess. And other labels that were inspired by the OpenShift repositories were in priority. They had important long-term and important soon labels that basically meant the information about the priority in time. So these kind of label would change in time, coming with a new version or a new release. I also inspected that some OpenShift repositories had story point labels. This is a neat feature, but the question is if we really need this, because it would be useful for analysis, for us to see, for example, who takes the most, let's say, hard story point issues. But if a person outside of the team looks at the repository, it would say nothing to the person actually. So I don't know if this is important. It is important for our analysis, but it just does not meet the use case for other people outside the repository. And also you would have a standalone labels like good first issue and version label, which I think is maybe important to have every issue labeled with version so the contributors know to which version was issue specified for, and you would have help wanted. I expected that all the OpenShift repositories have this kind of label. I don't know why, but I just think that it meant help wanted. So yeah, probably we would just use help wanted label, not the emoji thing. And the last thing is I also encounter the needs feedback label, and it is somehow a requirement label in my opinion, because, for example, when someone posts an issue and you as a team don't know if it should be accepted or not, you can label it needs feedback. So a community, if you have a large community, the community can respond, or you would fix some bug and you would need a feedback from the person who created the issue. So you would also label the issue with the needs feedback requirement. And the idea is that in order to complete an issue or to issue, or in order to enter the final state of the issue, so the accepted, completed, or rejected state, you would need 0 requirement labels. And that's about it. The link is in a demo document, and I engage you to express your opinion about it in the comments, and we can get new ideas perhaps, or reject some of them. So thank you. That's probably about it.
Okay, thank you, Dominic. Are there any questions?
I actually have a comment on the story points.
Yeah.
I feel like it does convey something important because it's like for the complexity of the issue. So it might be like maybe don't use the word story points because it doesn't have as much meaning to people outside, but it does have like an actual meaning. So we could use like complexity there instead. That way it maintains some sort of like meaningful data.
Yeah, that's actually a good idea. Like, you mean to have a complexity label and not to use numbers, but for example to use a word expression for the different levels, I guess.
Or it could just be like a scale. So like you could still use the number scale.
All right. Oh yeah. Yes. Okay.
So this is an offline discussion. I would, for example, disagree with complexity, but let's not discuss it on demos.
Okay.
By the way, it would be good to sync with Tomáš Tomešek because he did a tool that syncs these story points and reports for managers. So check what he did on this front and if we can reuse his work.
All right.
Any other questions? If not, Francesco, are ready? So thank you, Dominic, for the demo, and let's try Francesco again. We cannot hear you. We still cannot hear you. Okay. So we will give you more time. And meantime, the next demo is by Marek and it's about Argo Python DSL.
All right, let me share the screen. Can you see it? Can you see the presentation?
Yes, we can see it.
Perfect. All right. Let me just enlarge it. And these are just a few slides, so don't worry. Okay, so Python DSL for Argo workflows. So we've basically migrated our workflow management to Argo in recent days, or at least most of our workflow management. We work also very much with Python, so this is something that comes very handy for us. But what is it? Okay, what's DSL? Well, DSL in general is a domain-specific language, and it should provide some sort of an easy-to-use and user-friendly abstraction. Argo workflows are defined as manifest files. You can see it on the left side of the screen. This is an example of a simple Hello World workflow that is composed of just one template, and that's whale-say, and that runs in a container and just outputs Hello World. And on the right side of the screen, we can see an example how that would be written using Argo Python DSL in pure Python in an object-oriented way, just by subclassing this Argo workflow. We have all of the Argo manifests generated from Argo OpenAPI specification, so we try to stay as close to it as possible. And we also want to integrate all of these purely from within Python. I'll show you more examples later on. So why is it useful? Why Python DSL? So first of all, it's a direct integration with our Python applications. It integrates seamlessly with Argo Python SDK, or the client, as we may call it. We just define the workflow purely in Python, and we can submit it directly to the cluster where it is picked up by workflow controller and executed. We can also make use of some Python features. I will show you that later, mainly closures and scopes, and that is something that is very custom for us and that sort of diverges from Argo language, but hopefully it will be useful. We can also generate and template the workflows. So imagine you have a huge YAML file and you want to template some variables. So you typically use Jinja for it. And Jinja's, if you've seen Jinja, you know, it's just pain. And also testing. You can test pieces of code that is written in Python before you actually include it in the workflows, or you can test the workflows itself, in fact. So I say, why is it useful for us? So who are we? So we're a growing community of Argo workflow users and mostly Pythonistas. We're Project Thoth from Red Hat, and we like to use Argo for our applications that mainly focus on recommending software stacks for artificial intelligence applications. We're also creators of Argo Python client, as I've mentioned it before, which is a simply client generated from Swagger that provides the models for Argo and allows us to manage Argo workflows purely from Python. And we're also whoever wants to use Argo workflows with or without Python. So what can we do with it? Let me switch to a quick demo. In the repository, there are links at the end to the repo. There are a couple of examples here, and the examples are structured so that you see a YAML specification, for example, the Hello World one, and you see a corresponding IPyNV file that is a notebook that defines the Python class for it. So here is a simple YAML definition of a workflow that I showed you before, and all you have to do is define this class. Now, when you instantiate the workflow, there is actually a hidden parameter that is set to true, and that's the compilation. And what it does during the compilation is that it basically replaces all of these fancy templates. There is a lot of meta programming behind that, so it replaces all of these with proper Argo models. And this is just to test that these manifests generated and loaded really match, because we use also these notebooks for testing. But let's skip this hello world thing, and let's see that we can also define some, let's say, more difficult workflows, like this DAG diamond workflow. That is 4 tasks and some eco template. You can do that pretty much in the same manner. You just define these tasks as functions with parameters up here, and down there there's this eco template, very much similar to the hello world example, instantiated, and you can see that the definition of the workflow is really the same as the manifest file. You can also define artifacts in there and any other features that Argo provides, really, or at least hopefully you can do that. Sometimes there are slight changes from the YAML specification because of Python. For example, this from keyword is underscored, but hopefully this won't be a major issue for you. And lately, and lastly, I mentioned closures and scopes, and that is something that may be pretty useful. So let's look at this. So here you have a piece of Python code that you just want to execute as part of the workflow. And this is the way that you would do it in the actual YAML file. You have these 3 lines as a raw piece of code here. It's not testable. You can very easily create a typo in here, so the whole workflow fails, etc., etc. This is how we would define it here. But we're working with Python, so why not make use of it, right? So let's go down here and let's get to closures. So a closure is, in our language, in this DSL, is that you just define the function normally as you would from within Python, and you just wrap it in a closure and specify the image that should this closure be executed in. There are some plans for the future that we would not need even that image specification because of our analytics over source code, but right now you just have to specify the image that should run here, and that's it. The result is exactly the same. There is a script generated from this closure, and you're good to go. What scope is, and I don't have an example for it yet, just yet, but what scope is that you basically can bind multiple closures in a single scope, and these scopes share the environments and the variables in it. So that might be useful if you have multiple functions and you just want to use code from one function in the other one. And there are other examples. If you want to take a look at these, please feel free to do so. So there are some questions that are commonly asked, like how does it compare to Kubeflow DSL? So Kubeflow DSL is much higher level abstraction specific for Kubeflow pipelines, whereas Argo Python DSL uses pure Argo models to define a generic Argo workflow in an object-oriented way. So it's basically a low level. There is no, except for the closures and scope, there is no abstraction of these workflows. So you can say that these Kubeflow pipelines and this Kubeflow DSL can be in the future based on Argo Python DSL. by just simply extending it with their own logic. And of course, how can I contribute? So take a look at Argo itself. Feel free to join the community on Slack, and feel free to contribute to the Python DSL. This link might change. Right now it's under my repository, but in a matter of weeks, max months, this should be migrated under Argo Project Labs, which is sort of a daughter organization of Argo Project, and you should be able to find it there. That's it. Any more questions I can answer?
So can I ask a question?
Yeah, sure.
I didn't quite catch if you could possibly repeat what was the compilation parameter you showed at the beginning.
Yeah, sure. I can even show you.
Okay.
So just make sure that I'm running the correct piece of code, and let's load it. So if you don't compile it, there is this template, which is basically a decorator of this function. And if you don't compile it, you just see this thing here. So that means that the template has not been yet compiled into Argo model. And it's basically just a Python class. So in my words, compilation might not be the happiest term, but it basically means turning this Python object into Argo model.
Oh yeah,
Is it a sufficient explanation?
It's absolutely clear. Thank you.
Okay. Thanks for the question. Any other? All right. Thank you then.
Okay, thank you, Marek. And we can try again, Francesco.
Should be fine now.
Yes, finally.
Damn it. Okay. Unfortunately, I had no idea why Blue Jeans is crashing, but anyway.
Me too.
Let's go to the point. So I'll share my screen. Can you see my screen?
Yes, we can.
So I will talk about two topics quite quickly. And basically there are two notebooks. The first one is useful to basically analyze advisors' results. So every time advisor is used in one of the use cases that Thoth can be implemented, one of the results are going to be stored on Ceph. And what we do, basically, we retrieve this information from Ceph and try to analyze and see what are the main type of advices that we are providing. And in this way, we can try to improve them to give a better experience to the users. And we can also see what needs to be improved. For example, in terms of performances or in terms of action that the system needs to take internally. Just to give you some example, I can go directly to the notebook. So the first notebook, as I said, is the one related to advisor justifications. This type of justification are provided to the user. I collected some of them just to show some typical example. For example, if we talk about the Thoth implementation in GitHub app, this is what we provide as a check run at the end. So the user open a pull request, and advisor and Thoth and advisor run in the background, and we provide some, let's say, justification of the results of the advisor if there is a software stack provided. So, for example, in this case, I don't know if you can see, maybe I can go a bit closer, yes. Here you can see that there is an invalid application stack supplied, so advisor is not able to act on it, and so the user should take some action on that initially. Some simple one is when basically the repository does not contain any pip file, so we cannot provide any advice on that. If we do not have observations regarding some specific runtime environment, for example, in this case for CentOS 7, Python 3.6, and all this information are actually all useful for us because we can use basically data-driven engineering to try to focus on what the user are working mostly. So if we don't have enough observation regarding some specific environment or some specific packages, we can already take action on that. And that's why one of the reasons, for example, why we want to see and why we collect all this observation. So the notebook is pretty simple. Basically, just use our libraries to connect to Ceph, and there are some functions that basically collect this knowledge and take the information regarding the justification, if there are errors regarding to the justification, and extracting this information. Basically, at the moment, I found 2,500 advisor run since we started using the app on GitHub, and they all contain basically all this information regarding the analyzer version, so the version of advisor that is used, and the type of messages. It's quite simple for now, but these are the meaningful information that we are analyzing right now. And thanks to this preliminary extraction of results, here I'm just filtering for the things I need and hiding in order to plot in a meaningful way. And basically what you get at the end is the type of every justification is basically encoded in order to be plotted in a meaningful way. But you can see the different types of justification that we're providing. And this is important for us because we want to, as I said, improve the user experiences. And if we go and look at what we do with this information, we actually want to see them, we create some metrics out of them. So basically at the end of this notebook, so there is a way to send the metrics to push gateway, and Prometheus is going to scrape them, and we can actually see them quite easily in one of our dashboard. So we can immediately see what are the most, let's say, provided the advisor. And for example, here we can see that there are many regarding some software stacks. This is at the moment based on our repositories, but this means that either we need to, for example, change some of the inputs that we are providing, or that we want to do something about this specific software environments. And I think it's okay for this first notebook. I don't know if you have any questions regarding that. Otherwise, I will move to the second one.
I have one question I probably missed. Is it aggregated from our stage environment or test environment?
Stage environment.
Okay.
So if you go here, yes. That's what we are looking at.
Are there any other questions? If not, the next one is yours as well.
Thank you. So we collect, as we want to provide information regarding the most performance software stack, for example, we collect observation regarding performances. So currently, there is one of our services called Amun that run and is a dependency monkey. It's scheduling different type of software stacks, and then Amun is gonna run the inspection jobs that basically run the script or performance indicators that we have in order to collect performance observations. And the inspection can be basically identified through an identifier. So if we want to focus on some specific type of observation that we want to collect in order, for example, to create a data set for someone or to easily identify what the observation we're creating, we can select. So this is based on this identifier. And the same, we are going to collect basically all the observation from Ceph. And I had to reduce the number of observation because basically it crashed, and I had to restart it quickly, but just to show you some results. But in general, basically we take the result from dependency monkey, we check the inspection batch created, and we verify which one of this inspection batch is the identifier we want to consider. And in this way, we extract this information. For example, regarding this inspection batch, just using a few of the dependency monkey document results, we have these batches. And in each of these batch, there should be around 100 inspections. Oh, yes. So now that there was a filtering again for reducing and to speed up the notebook because I didn't have time now. But as you see in all the inspection batch, there is 100 inspection, and the 2 actually is related to the Docker file and specification, which is included in the results of the inspection batch. There is a first filtering regarding possible errors in the inspection results. For example, here, as I showed before, we have 204, and 80 of them has some errors. So this is a first filtering that we have. But this is important also for us to understand what we can to improve. The second part is basically putting the information in data frames in order to visualize them in an easy way. And then we basically create some reports out of them. So if you want to see, for example, if all the inspections has similar hardware, similar runtime environment, similar performance indicators, or if you want just to be able to filter out if we want to plot the different cases. For example, here we can see the architecture, the hardware information, and the type of hardware. This is mostly related to the software stack. So as you can see, there is just one software stack. And we can see the packages in the software stacks and the base image used and the information regarding the performance indicator. The next step is basically to process these results in order to create the plots. And here you can see actually the software stack related to, sorry. Yes, that's a report. So basically, if you see, it's not one software stack, it's more than one software stack, but you can see for each of the packages which version have been used. Indeed, if you can see here, there are 2 software stacks actually. And is the same TensorFlow version, but we change some other parameters. In this case, for example, you can see that there is 6 that is different. Well, I had a better plot, but that's it. After that, basically, there is a filter. There is a filtering function. You can choose the runtime environment if you want to see, for example, just one of the packages. For example, it's TensorFlow or PyTorch, and basically you then go to the plots. I wish we would have already more, but again, sorry that for the BlueJeans problem. But if these plots basically will show the difference in the software stacks. You can see the software stacks in here, and basically see the results respect to the performances. This again is just focusing on the TensorFlow versions and the different. Here there is not much of difference, but hopefully with more analysis, we're going to see this difference more precisely. And that's it. Basically, the rest of the notebook is something that I already show. It's related to the analysis of the quality of the inspection. And that's it. I don't know if you have other questions. Otherwise, I end with my demo. With my part of the team.
Okay, thank you, Francesco. Are there any questions? If not, then thanks all who presented and joined. We will make this video available on YouTube, on our YouTube channel. So feel free to subscribe, feel free to follow us, and feel free to visit our ThothStation organization on GitHub. We will make a summary of this sprint demo, and we put this summary into the video description, so you can link and browse the whole content, as we are open source and open. So thanks all, and have a nice day.